Hello dear students and math lovers, welcome to my channel. Today I'm going to solve exponents, absolute value, linear equations and linear inequalities questions. Let's start. First question is about simplification exponents. It's written so just one of them because these are the exam questions. So simplify A or B. So I'm going to solve all of them, of course. Negative 3 squared means negative 3 times negative 3. And negative 2 squared means it's negative 2 times negative 2 times negative 2. So if we perform these operations, first two terms make 9 and last three terms make negative 8, which is negative 72. That's it. What about B1? We have negative 3 power of a squared b to the power of minus 3 over 6c, and in the second parenthesis square of a squared b to the power of minus 2 over 9c. You know, there are many ways to perform this operation, make this simplification. So I just take power of each term in each parenthesis. So I will have a to the power of negative 6. Remember, so power of power is multiplication. So b to the power of negative 3 times negative 3, which is 9, over. Here I have 6, and in the second parenthesis I have 9. It's better to write these numbers as their factors. So 6 I write as 2 times 3. So negative 3 power I apply to both of them, and I have c to the power of minus 3. This is the first parenthesis, and the second one is a to the power of 4 times b to the power of minus 4. 9 is 3 squared, so, and I have square of it, and c squared. Let's write here the important things. So what was negative 3 power of a squared? It's multiplication between the powers. So it's a to the power of 6, for example. So what was b to the power of minus 3? And then minus 3. These are from the first parenthesis. So b to the power of minus 3 and times b to the power of minus. Sorry, what am I doing? Yes. So it is, yeah, we don't need parentheses. Just here times minus 3, which is equal to b to the power of 9. So, and we use this property to every term in the parentheses. If we continue, this is multiplication, so I just show all the terms on numerator and on denominator. We have this like terms. Here we have a to the power of minus 6 and a to the power of 4. What it makes? Let's write them together first. A to the power of minus 6 times a to the power of 4. It's better at the beginning if we write like terms next to each other. And we have b to the power of 9 times b to the power of minus 4. In denominator I have 2 to the power of minus 3, 3 to the power of minus 3, and 3 to the power of 4 times c to the power of minus 3 times c square. Okay, now I perform here the like terms, these like terms in multiplication, so I add the powers. I use the same color. A to the power of minus 6 plus 4 minus 2. So for b to the power of 9 and b to the power of minus 4, it makes b to the power of 5. Let's write better 5. And here I have 2 to the power of minus 3. You see there is 3 to the power of 4 and 3 to the power of minus 3, which makes 3 to the power of 1, which is 3. And finally c to the power of minus 3 and c squared, which is c to the power of minus 1. So let's organize these terms. I move the negative terms to the other side of the fraction. I will have 2 cubed and b to the power of 5 and c over 3 and a squared. So the final result is 8 b to the power of 5 c over 3a squared. This is the simplest form. Let's continue. Second question is about absolute values, modules. There is a condition for a and b. A less than 0 and b is greater than 0. We have to be careful. What's the thing here? We have to understand for each expression inside of absolute values. So here we have b minus a, here we have 2a minus b, here we have minus b, and here we have a. We have to understand if they are negative or positive, because it's up to those expressions, negative or positive, we will write them, we will take them out of absolute value. So let's start from the monomials. Let's say from a. It's written a less than 0, so we know that a is negative. Let's write them here. So a is negative. Okay. And b is positive. We are sure about this. Where is b? Yeah. And in this case, a is negative. So inside here we have negative. Okay. This is negative. What about negative b? If b is positive, negative b will be negative. Okay. So what does it mean? Absolute value of a, how goes out? Can I write it as a? No, because a is negative. So, but out of absolute value, all the terms, all the expressions must be positive. I can make it positive only if I multiply it by minus. So minus a actually now positive. What about negative b? So negative b. Negative b, as you see, it's negative. So I should multiply it by minus to make it positive. I know that b is positive, and so in this case absolute value of minus b will go out as b, and so it is positive. For every term I have to find this. What about b minus a? Absolute value of b minus a. Sometimes it may be difficult to understand, to see if it's negative or positive. So we can make this. I just sign value for a and b, any values. For example, a is -1, b is 3. Up to condition, any numbers I can use. But you see, this is I do just to understand if b minus a positive or negative. So I write it here. b minus a. b I assign as 3 minus a. a is -1. So you see, it's positive. It's positive. It means I turn back, b minus a goes out as b minus a because it's positive. Okay, and later I will continue with these letters: a, b, a minus b, b minus a, 2a minus b. Continue. What about the last term? It's 2a minus b. Okay, so again, let's use these numbers to see if 2a minus b is negative or positive. 2a minus b. So 2a, a is -1, so 2 times a will be -2. And I have minus b. b is 3. b is 3. Okay, you see, it's negative. What must I do in this case? So I cannot write it as 2a minus b because it is negative. It's negative. What must I do? So I multiply this by minus, and now it is positive. All the expressions, all the terms in absolute values now out without absolute value. Now I rewrite the question without absolute value. What do I mean? First one is b minus a. So b minus a, it's b minus a. So I just write as b minus a. Second, we have a minus sign between two modules, and we have 2a minus b, and it goes out as minus 2a minus b. So I write it like this. So this is the absolute value of 2a minus b. And the third term is, we have a plus sign. We have a plus sign, and modulo of minus b, here it is b. And we have a minus modulo of a, it is minus a. Now I use only brackets, as you see. Now I will perform this. b minus a, minus minus is plus, so plus 2a, minus 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 is minus b. Plus b, minus times minus is plus a. Okay. So guys, do you see simplifications? Yes. Here plus a and minus a we can simplify. And here we have b and minus b. Okay. And what is the final answer? Final answer is 2a and plus b. This is the simple form of this absolute value question. Question number 3. Solve the equations. We have two equations, two linear equations. Let's start from the first one. 3 times, there is a multiplication. If we have a number in front of a parenthesis, it's a multiplication. 4 minus 2x plus 2 is equal to 17. So what are we doing, guys? If we have a number in front of parentheses, it means we multiply this number by every term inside of the parentheses. I have 3 times 4, which is equal to 12, and I use different color for the second term. 3 times minus 2x, which is minus 6x. and I continue, plus 2 is equal to 17. On the left hand side we have 12 and 2, which is 14, and I have minus 6x is equal to 17. I move 17 to the left hand side, so I will have 14 minus 17 is equal to 6x. Just to make the coefficient of x positive, I move minus 6x to the right hand side and 17 to the left hand side. And 14 minus 17 is negative 3. It's equal to 6x. If we divide both sides by the coefficient of x, we will get x is equal to negative 1 over 2, which is the root, which is the solution of the equation. This is the solution of A. What about B? We have 3x minus 2 over 3 plus 4x plus 7 over 6 minus 1 minus 3x over 12 is equal to 1. We have addition and subtraction of fractions, and what we do, equal denominators. Okay. Here 3, 6 and 12, we see that equal denominator is 12. So I multiply first fraction by 4 and the second by 2, third one I don't make any change. If I multiply by 4, I will have 12x minus 8. Okay, over 12 plus 8x plus 14 over 12 and minus 1 minus 3x over 12 is equal to 1. Now on the left hand side I have the same denominators. I can write all these fractions like one fraction with one common denominator. So 12x minus 8 plus 8x plus 14 minus 1. Here we have to be careful. This is the common mistake students make. So here we will have plus. This minus affect to 1 and affect to minus 3x. So minus 3x will be plus 3x all over 12 is equal to 1. Okay, and let's combine the like terms. We have 12x here, we have 8x, and we have 3x. Together we will have 23x, and we have negative 8 and plus 14 and minus 1. We will have and 5, right? Negative 18 plus 14 is 6, 6 minus 1 it is 5. So we will have plus 5 over 12 is equal to 1. And from here, if we make cross product, also we can see that 23x plus 5 over 12 is equal to 1, in which case it's possible. What division gives the result 1? If we divide the same number by the same number. So 23x plus 5 is equal to 12. So 23x is 12 minus 5. 23x is 7. If we divide both sides by the coefficient of x, we will have x is equal to 7 over 23, which is the answer, the solution, which is solution of the equation, root of the equation. Fourth question, solve the inequalities. S missing. So we have two linear inequalities here. 2x plus 3 less than x plus 1, and the other one. Let's start from the A1. Solving inequalities starting the same as how we solve equations. So 2x plus 3 less than x plus 1. We combine the like terms on the same side. So here we have 2x, and I take this x right to the left hand side as minus x. I don't make any change on the inequality sign. I have 1 on the right side already, and this plus 3 I write to the right hand side as minus 3. If I continue, I have x less than negative 2. But this is not enough answer yet. So x less than minus 2. What does it mean? I have to show an interval method, and I have to show on number line. Let's draw a number line. Okay, and with this number line, let's show. So here if we have 0, so negative 1, negative 2, negative 3, 1, 2, 3. Enough. X less than minus 2. It doesn't say less or equal to. So we have to start from minus 2. But here inside will be open. How can I show this? Yeah, good idea. I change the color. So minus 2 doesn't belong to the answer. Less than is the left side. So this is the solution of the inequality system. So all the numbers on the left side of minus 2. And how do we write this? With interval notation. X is an element of, we know that here we have negative infinite, and the right side we have positive infinite. From negative infinite till minus 2. Negative infinite is always open, and here also at minus 2 also it's open interval, because it says it's less than minus 2. If less or equal to, we will write closed interval. We will see it in the next question. Next question, we have 3 plus 2x minus 3x minus 1 over 2 less or equal to 3 plus 1 minus x over 2. Before to start, we see that we have same number on the left side, on both sides, so we can simplify these 3's. So it makes our operations easier. So here we have 2x, and we have fractions, so let's make the denominators equal. Here we have 1, so I multiply it by 2 to make all the denominators 2. If I solve it, I have 4x over 2 minus 3x minus 1 over 2 less or equal to 1 plus x over 2. Okay, so I write it with one denominator, with one common denominator. 4x minus 3. Yes, we have to be careful here. This minus change, and you will have plus. Minus times 3x is minus 3, and I forgot here x. Okay, and then minus times minus is plus 1 over 2 less or equal to 1 plus x over 2. We have same denominators on both sides, and it's a positive number. Actually, we can multiply both sides by 2 just to eliminate these 2's. If we multiply both sides by a positive number in inequalities, it doesn't affect the inequality sign, so it doesn't change anything, but I can simplify these denominators. So I have 4x minus 3x plus 1 less or equal to 1 plus x. I will have x plus 1 less or equal to 1 plus x. Okay, x plus 1 less or equal to 1 plus x. And I realized that here I had minus, but I write here plus. Let me correct it. So, sorry guys. Making mistakes are okay if we are learning from our mistakes and if we see them on time. So we have 1 minus x, 1 minus x. Okay, if we continue, we will have, so I collect x's on one side and the numbers to the other side. 2x less or equal to 0, which is x less or equal to 0 when I divide both sides by 2. X less or equal to 0. What does it mean? How can I show this on number line? Where is our line? Here it is. It's coming. Okay. And we have 0 here. Negative 1, negative 2, and here I have 1 and 2, and we have less or equal to 0. So 0, you see the difference between this and previous one. It was x less than minus 2, so the point is open. Here point is closed. Less than, so again we have the left side on the number line. We shade the left side of 0. And how can we write this? We can write this as x is an element of, all the time we are writing from left side to the right side the interval, so from minus infinite till 0, but in this case 0 is closed interval. Previous one, x less than minus 2, it's open. Here less or equal to, it's closed interval. When it's equal to, we use closed interval. Fifth question, use the graphing method. So we have to use the graphing method to solve the equation system. We have two linear equations. It's always good to name the equations in a system. So I mean, how can we name the equations? I sign as the first and the second equation. To use the graphing method, we need to make tables. So for the first equation, sign table we have to make. So for x and y values, it's negative x plus 3y is equal to minus 3. So if x is equal to 0, what is the y value? If x is equal to 0, so I can show it here for the first equation. Yes, I have negative x plus 3y is equal to minus 3. If x is equal to 0, 3y is equal to minus 3, y is equal to minus 1 in case x is equal to 0. So I put this on my table. So if y is equal to 0, minus x plus 3 times 0 is equal to minus 3, minus x is minus 3, x is equal to 3. So if y is equal to 0, x is equal to 3. Okay, so here is the case. And I make the same table, but before that I show this on my coordinate plane. We have 0 minus 1 x 0 minus 1. These are my points, first point and second point. So 0 minus 1, it is x0, y is minus 1. Here it is. And x is minus 3. No, x is 3 actually. X is 3, y is equal to 0. It is not minus. Okay, x is 3, y is equal to 0. And then I will have my first line. Let's draw it. This is my first equation. Instead of writing the whole equation, I write just one. What about the second equation? I put the points. I find the points here, and I make my table here. X and y. So if x is equal to 0, what do I have? My equation is 5x minus y is equal to 15. If x is equal to 0, you see y will be minus 15. So, and I don't have minus 15 here. So it's better I select another number. For example, if x is equal to if y is equal to 0, let's find first, then, okay, why not? If y is equal to 0, I will have 5x minus 0 is equal to 15, x is equal to, here is 15, x is equal to 3. Okay, this is good, because I was planning to take the point 3, so it's actually coming from y is equal to 0. So this is the case where y is equal to 0, x is equal to 3. Alright, and this is the same point actually here. We have one common point. This is nice. And let's find, we need one more point. So if I take, let's say, x is negative 2, okay, positive 2. Let's select better numbers. I think minus 2 is better, yes. So if x is minus 2, let's calculate it. 5 times minus 2 minus y is equal to 15. How it is 15? So, sorry guys, I don't know why, but thought it is negative 15. So y is equal to 0. Yes. Let's take x as 4. If x is equal to 4, 5 times 4 minus y is equal to 15. So 20 minus y is equal to 15, and y is equal to 5. What was x? X was 4. So for 5 we have 5. For 4 we have 5. X is equal to 4, y is equal to 5, and this point, let's show. So we have 3, 0, which is here, and 4, 5. X is 4, y is 5. 1, 2, 3, 4, 5. Here it is. So now I have to join these points. I can use different color actually. Yes. Okay. And this is my second equation. So guys, what is the idea? Let me add the points. So 3, 4, negative 1 and 5, and the intersection point, as you see, it is 3, 0. 3, 0 is the intersection point. It means 3, 0 is the solution. I have to write this of the system. 3, 0 is the solution of the system. I hope it's understandable. And last question is, use the elimination methods. We use the elimination methods to solve the equation system. What was the elimination method? Let's write the system first. We have 3x minus y is equal to 17, and 3x plus 2y is equal to 20. I again name the equations as first and second. This is my equation system. There are two variables in a system, x and y. To use the elimination method, I have to select one of the variables and make their coefficients equal but with opposite sign, equal, just to eliminate them in addition. Okay, so we see that already we have same coefficients for x, so it will be good if I multiply the first equation by minus 1. What will I get? I will get negative 3x plus y is equal to negative 17, and I rewrite the second equation, 3x plus 2y gets 20. Oops. If I add this equations, you see 3x and negative 3x in addition cancel each other. I have y plus 2y, which is 3y on the left hand side, and on the right side negative 17 plus 20, which is 3, but let me write it. So let me show the addition. Okay, so I have y plus 2y is equal to negative 17 plus 20. We have 3y is equal to 3, and from here we have y is equal to 1. This is the y value. But we didn't finish. We have to find and the x value. How do we do that? We take first or the second equation. Okay, I take the second equation. What was it? 3x plus 2y is equal to 20. 3x plus 2y is equal to 20, and I will substitute this value in the equation instead of y. So let's do it. 3x plus 2 times 1 is equal to 20. 3x plus 2 is 20. We add 2 by a number and we get 20, so this number is 80. 3x is equal to 18. If we divide both sides by 3, we have x is equal to 6. So x is equal to 6, y is equal to 1. We have solved this, and we have to show this point, this pair, 6, 1, pair of x, y is the solution of the system. That's all for today. I hope explanations were clear. I hope you understood. I hope these solutions help you. See you next time. Bye bye.